Hello and welcome to this tutorial. Today we'll be talking about plot variables or output variables and what they are, how they're useful, how to edit them, modify them, or add them. Let's jump right in. What is a plot variable? In an XPlot file, here's one of my spine models. If we come to this top bar, we see this drop-down menu with a lot of different options. Each of these represents an output variable that we might be interested in. Maybe we want to know how much torque or how much stress or how much contact force, contact gap. Like these can be really useful parameters in research or in understanding the model. For example, we are typically very interested in the Euler angle. So it gives us an angle in radians as to how much the skull flexed. Very important if you want to tie your shoes, right? We're also very interested in stress. We've been using effective stress, and you can kind of see here, there's like a hot spot on this lateral, kind of postural lateral corner. And so that's very important. This is where degeneration typically happens in our intervertebral discs right here. However, a colleague of mine recently reminded me that, oh, the collagen fibers that give the intervertebral disc its strength, they don't fail like normal materials that we might use effective stress for. They fail in tension. And so he recommended using the fiber stretch variable rather than effective stress. So I figured now is a good time to make a video talking about how you can edit the plot variables to do that for you as well. You'll notice fiber stretch is not included by default. How do we add it? I'm going to go over two ways to add a plot variable. This is the FEB file corresponding to this XPlot file, and I'm going to drag and drop to open it, and you'll notice it gives me an option, edit XML or import as model. Can you guess what the two methods are that I'm going to talk about? So I'm importing as model. We're going to do it in FEBioStudio with this view first. Basically, to add plot variables, we need to come all the way down. I'm gonna hide those to output. You can expand output and bada bing, there's plot file with all of our plot variables, all the things that we're interested in learning about. The log file is also important. This tells us about how the model is being solved. And so this can be very important for troubleshooting and kind of gets into the numerical methods of the finite element method. So typically we'd come in and say, okay, edit plot variables. We click right here and this window pops up and, oh, here's a list of potential plot variables or the most common plot variables. There are a lot. So rather than hunting through this, I'm just going to filter and I'm going to type fiber. Okay, here we go. So we have deviatoric fiber stretch, fiber vector. For more information on these, you can go to the FEBio user guide, user manual, or also the theory manual, and it might have information on the plot variables that you're interested in. And if I simply select this little box and hit save, then boom, fiber stretch shows up right where I want it. Now, when I did this, it didn't come out as I wanted. It just simply wasn't working. There was no color coding, everything was gray. And so I had to go to another very valuable resource, which is the FEBio Forum. So here at forums.febio.org, we have a lot of resources because a lot of people have the same questions that we have. So we love them for having these questions and solving them and sharing those answers. So I actually found this forum post, how to visualize fiber stretch. Okay, visualize fiber stretch. That's exactly what I want to do for multiple solid mixture materials. My intervertebral disc material definitions are multiple solid mixtures. I'll talk more on that in a sec, but basically, okay, maybe this is why the traditional fiber stretch wasn't working for my model. Okay, so scroll down here, and then we see Steve Moss, who actually is the lead co-developer and a very nice, very good guy. He has a solution. Oh, you can use the fiber stretch solid1 equals fiber stretch 1 plot variable. Let's try it. And so we can come here, edit plot variables, and this time, instead of finding it, we're going to click add here in the bottom left corner. Add, and rather than typing all of that he had, I'm just going to copy and paste. So no need to include the quotation marks in this case. Control C to copy, click back over here and paste. Hit OK. It's automatically checked. Save fiber stretch 1. Excellent. When I tried this, it still didn't work. And after some emailing with Steve, Dr. Moss, I found that adding the second fiber, because I have 2 fiber families, by including both, that's what made it work. So if I come in to edit plot variables, hit add again, and paste, but this time instead of solid 1, I'm going to do 2 equals fiber stretch 2. So there we go. Fiber stretch solid 2 equals fiber stretch 2. So save, and now we have both of these. Excellent. We are ready to go. From here, we can run FEBio and it'll work. Let's move on to the second method. I'm going to close this. All right. We could drag this in and hit edit XML, but I actually prefer to edit the XML in a different application. So I'm going to cancel and right click on the FEB file and edit with Notepad++. I just find it's a little easier. So here it is. This is our FEB file. Once again, we have all the same parameters in here as we did in FEBioStudio. So we start out with control. This has our, okay, so it's a quasi-static analysis. This is our time steps, our linear solver. All of that can be controlled from here. Globals, constants. This is our material definitions. Okay, and so if we scroll down to, this is what the name of one of my invertible disks is. So this is material 9, and it is a solid mixture. And so our base is a Holmes-Mao, and we have fiber family 1 and fiber family 2. And then here is our next one. So material 10 is, again, a solid mixture, Holmes-Mao, fiber exponential power, but this is the next disk down. So this is all of our material definitions, and those are the fiber families that we'll be visualizing. This is our mesh information. So node 1 is at location X, Y, Z. These are the coordinates. Node 2 all the way down through all the nodes. This is the elements. Okay, for every tri3 type element, these are the node names or node ID numbers that make up this element ID 1. Here are the others, so hex 8 elements. Okay, here are all 8 node IDs that make up that hex element, etc. There are a few of these. So close mesh domains. This defines our shell materials, shell thickness, and our mesh data, boundary conditions, rigid body constraints, loads. All of this can be seen in FEBioStudio as well. Contact definitions. Again, this can be seen in the model viewer on the left-hand side in FEBioStudio. Our discrete materials or spring elements these can all be edited right here in this XML file. We could totally just say, actually, you're going to move location. But we're not going to do that because that might cause problems. Here are our load controllers. And finally, at the very bottom is our output. We could have simply hit Control F to find and gone, okay, plot file or output, and it would have found it very fast for us. And so here we're going to come and we're going to say, okay, if I paste what I had before, notice it doesn't really match what's here. So we're actually going to have to type var type, just like in these lines above. We're just going to copy that same syntax. We're going to add the quotation marks, and then close out with the same syntax as above. Then we have to do it the second time. Var type, type equals quotation, paste, and this time I'm going to change this to 2, fiber stretch, 2, quotation, closed. There you go. So we're all ready. And now we can just save and then exit out and run. You could run it from the command line or run back in FEBioStudio. So now that that's all ready, rather than letting it run, I actually have the result right here, where if we drop down, we can see, okay, fiber stretch. Oh, yep, gray. I don't know why it didn't work, but if we come to fiber stretch 1, bada bing, bada boom, it's right here. You'll notice there are hotspots on this side, and in fiber stretch 2, the hotspots are actually on the other side. And that's because our fiber families oppose each other, just like in real intervertebral disc. So that's that. That's how to add and edit the plot variables in FEBio. We also talked a little bit about the FEBio Forum. Go check that out. I hope it's helpful. It has been very helpful to me. Typically, people are very good about responding very quickly. So I hope it helps. Hope you learned something. Have a good day.